So alright, now let's explore about the IO view of this studio. So to get the IO view, you have to go to the debug, then click on Windows. After that, click on IO. Alright, so this is the IO view of your microcontroller. So here these are the various peripherals which are there in your microcontroller. So for example, if I click analog to digital converter peripheral here, so when I select here, you can see at the bottom, these are the various registers which is related to the analog to digital converter. For example, if you can take this register, this is ADC control register. This is its address. All right, this is a peripheral address, and its current value is 0, and these are the bit status. All right, so currently it is all are zeros. All right, so similarly, this is for the control area network, and these are all the register, and this is for digital to analog converter, and similarly our GPIOs will come under this parallel input output controller, that is PIO controller. All right, so for example, if I select say port A, these are all registers which are corresponding to configure the GPIO port A. All right, for example, this is a port enable register. Okay, so which is at the address, this is the peripheral address. Okay, and this is the current value. And there are 3 registers which we are going to use in this video. That is this one, PIO SODR. So that means set output data register. So if you want to make your GPIO as high, then you have to write into this register. So when you expand this, here you can see it has 32 bits. Okay, this register has got 32 bits corresponding to 32 GPIO pins, isn't it? And this is the clear output data register. So if you want to set your GPIO status as 0 or low, that we call it as a clear operation, then you have to use this register. Okay, and remember that these 2 registers, that is set output data register and clear output data register, they are write only registers. So here is a data sheet of the Atmel SAM3X80 based microcontroller. Here you can see PIO controller set output data register, that is PIO SODR, that is corresponds to this, and this documentation says that this is only write operation is permitted. Okay, write only. Okay, so you cannot read from this register, so that's why so whatever you do to this register, this value will always be 0. All right, so because your debugger cannot able to read these values. So here you can see this is the API, okay, which tries to make our LED high. Okay, so our LED is connected to GPIO number 27 of port B, right? So this you have seen in the previous section where when I was explaining writing a code to toggle the LED, isn't it? So this is a LED which is connected to the GPIO number 27 of port B. All right, so we are at port A. Let's go to port B. Okay, so here if you want to make the GPIO as high, then you have to write to the 27th bit of this register. So that's what this API is doing. So let's get into that. Just click step into. Here you can see it is changing SODR register, isn't it? All right, so now let's put a breakpoint here and run until here. So here we changed the SODR register. Here you can see our LED goes high. Okay, so but the SODR is still showing it as 0. That's because you cannot read this register. You can only write into that register. Okay, So but there is another register called ODSR. Okay, this ODSR stands for output data status register, and here you can see that this red mark corresponds to the bit number 27 and it is highlighted with the color red. So that means the bit 27 is actually set to 1. Alright, so check the bit 27 here. Here it is marked as red. That means the bit 27 is currently set. Okay, so here you can see our LED is also turned on, right? So now let's see what happens to this, okay, when we execute PIO set pin low. Okay, so let's go to our main. Let's keep a breakpoint here. Execute. So now we are about to turn off the LED, isn't it? So let's get into this function. Okay, and let's run. So here you can see this red mark is now cleared. Okay, so that means we cleared the 27th bit, okay, by using CODR register. Alright, so the change you do to the SODR register and CODR register is actually reflected in ODSR register. So great, so now we have turned off our LED, isn't it? Alright, so now you can even access this set output data register and clear output data register directly from this IO view. Okay, so directly I can control the LED from this window. Okay, so let's see how you can do. So we know that SODR register is actually write only. So that means I can even write to this register by using this window itself. Okay, so that will turn on your LED. For example, let's go to the bit 27 and click on this bit. Just click on this bit, okay, bits 27. All right, so here you can see our LED is turned on. All right, so now if you want to clear that LED, okay, go to CODR, that is clear output data register, and then go and click on the 27th bit. Okay, this one. This will turn off your LED. Here we go. So our LED is turned off. Okay, so that's the power of the Atmel Studio. By using its IO view, you can directly touch the registers and you can debug your code. Great, so that's about decoding the IO view of the Atmel Studio. So it's very powerful. So you can reproduce this at your desk and you can try out a couple of registers related to GPIO or related to any other peripherals like ADC, UART, etc.